Hello there. Today we'll be doing a problem called count good nodes. This is our 61st problem. Yes, 61st problem. I think this is a pretty good problem as well. Let's get it. Here we have a pretty bad solution with a counter, and we're just counting all the nodes that are greater than the previous node. That greater than or equal to the previous node, and that's how we do it. Yeah. The maximum greatest node in the parent node. So basically, it's a pre-order because we want to look at our item first, then go forward. We don't want to go forward, then look at our item, or go forward, go back, and then look at our item, which is in order and post order. And so let's wipe this code and let's get it. So another way to do this, instead of using a count, which is pretty inefficient, is create a definition called DFS. And what we're going to do here is we're going to take in the roots and the max value. And what happens here is that we're going to check if not root, we're just going to return 0 this time. That means we're going to be returning information in our node, so that we're going to add up the nodes that meet this requirement. So let's say our output is equal to 1 if our root.val is greater than or equal to max val, otherwise 0. Then we're gonna make sure we have our max val is the current max val, so max of max val and root val, because root val can become smaller, and we don't need we just need to get the max one. So then we can do a DFS call on the roots.left, and we're gonna put in the max val because it's the same parent, so it has the same max val, and plus the DFS of root.right max val. So they'll go down into their parent and find out if they is a good node or a bad node, or if we've reached the end, and then we return 0. So res plus equals these two items, and then we return the results. Of course, this is a recursive, and we go into the tree until we get to the base case that there's no root node anymore. So we're going to do an entire tree. So anyways, let's return the DFS of roots and root.val, because root.val is greater than or it's equal to the max val. It's the same. Right, this is not res, this is not output, it's output. Right, result is result, output is output. I don't know where result came from. Memory challenge. Submit. And here we go. Still pretty bad score, but it's better than nothing. I think it's cleaner this way as well, because our code is now a little bit neater. A way to make this even neater is reduce the number of lines and just put this in here. This operation shouldn't take too much time at all, this max here, and we could reduce this line by 1, and I would recommend that. I mean, run the code and submit. Yeah, wow, just removing 1 line of code I think helps a lot. The assignment takes too much time, it seems. Anything else we can do? No, I think that's it. That's all. That's all we can do. Yeah. How about how about Uh-oh. Scary stuff. Oh, we did not get the correct answer. How about... run the code? Maybe, maybe not. Oh, that did not go so well. So... I don't know exactly. Maybe that? Run? Maybe? Yes. Yes, there we go. Wow, that's interesting. So, I guess this is how people play around and try to minimize the amount of code we need to write. But it is kind of dumb. It just makes it completely not readable. Let's just go back to the point where it's the most, we have the most best readability, which is right here. I think that has the best readability. And it also was, I think, the fastest for some reason. Yeah, don't know why. But there it is. I hope you learned something today, and that thing that you learned is, let me review, is that we needed to do a pre-order so that we can get you gotta pick out which order you want to get the amount of information you need so that you can return to get the information you want from the problem, which is pre-order in this particular situation. And yeah, and that's it. I hope you enjoyed the video. Like and subscribe, and if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.